All right, we got ourselves some composite functions in this section. We're dealing with functions. I know this is 5.1. It's like, what? We're throwing in chapter 5 here? But they do relate very well to our functions that we're dealing with here, so we like to toss them in to this one. So let's get to it. We've done operations with functions. I think it's time for some composite functions. That f of g, g of f, awesomeness that you love so much from Algebra 2 Honors. Let's get to it. So we have f of g of 1. Now, the way I like to think about this is working my way back. So I'm going to plug 1 into g. So if I did g of 1, and I'm going to actually backtrack it just a sec. Some people like to write it like this, and that makes more sense to them. They see that the g of 1 is inside the f. So if I figure out what g of 1 is first, which would be 4 parentheses 1 cubed plus 1. When I figure out what that is first, well now, let's see here, that's 1 if I cube it, right? 1 times 4 is 4 plus 1 is 5. So g of 1 is 5, and now I'm going to plug that into my f. So now I'll have f of 5, which would be 2 times 5 squared plus 3. So exponents first, 5 squared is 25. 25 times 2 is 50, plus 3 is 53. So that would mean that f of g of 1 is 53. There's my final answer. Excellent. Wonderful. Fantastic. All right. I'm going to skip over B because it's kind of the same deal, but then I'm going to go into I would just be reversing. I'd go into F first with that one and then plug into G. So I'm going to hop over to part C here to try and keep this video a little bit shorter. But again, if you have questions, we can do more examples in class. All right. So F of negative 2. So I'm going to plug negative 2 in first. And what I'd have here is F of negative 2 equals, so 2 parentheses negative 2. Parentheses are so very important in these situations when I'm squaring stuff because negative 2 squared is positive 4. 4 times 2 is 8. 8 plus 3 is 11. So f of negative 2 is 11. And now I'm going to plug 11 into my f function to continue and finish this one out. So I'm going to have 2 times 11 squared plus 3. So 11 squared is 121. Double that, we get what? 242. 242 plus 3 gives me 245. So that would be f of negative 2. So we end up plugging into that f function twice. Same idea for part D here. Negative 1 goes into G, and then that number goes into G again. All right, but there we go. Not too bad so far. A little review action. Let us continue. All right, so now we have tables. We're going to look at 3 representations here. The next one, you guessed it, is going to be a graph. So we're dealing with tables here. If f and g are polynomial functions, use the table of values for f of x and g of x to complete the table of values for f of g of x. So that means that whatever x value I have, I'm going to plug it into g, and whatever number I get for that, I'll plug it into f, and that resulting number will end up in this table here. So let's start with this, negative 2. So whatever I get for this as I'm going through it is going to go right here, okay? So negative 2 plugged into g gives me 4. And if I take that 4 and I plug it into my f function, I get 7. So that means that this would become 7. Now let's continue. Negative 1, when I plug it into g, gives me 1. So if I plug 1 into my f, I get 4. 4 goes right there. If I plug 0 into g of x, my output is 0. If I plug 0 into f of x, then I get 3. If I plug 1 in, I get 1, and if I plug 1 into f, I end up with 4. And then the last one, 2, being plugged into or substituted into g, so g of 2 gives me 4. If I plug 4 and then to f of x, I get 7. All right. You'll notice there was a minor mistake here on the notes, so fix that for you if you decided to print them out. All right. Good, grand, great, fantastic, wonderful. Excellent. All right, last thing we're dealing with, graphs. We're going to evaluate a composite function from a graph. I remember struggling with these the first time around. It takes a little bit of time here to get used to it, but just be careful. So let's start. So we have our y equals f of x right here. We got our y equals h of x here, f of x function, and we got our h of x function. Awesome. I love it. So if I have f of h of 1, that means I'm plugging 1 into my h function first. Let's find out what that is. So if I have 1 going into my h function, my output is 1. I'm right here. So if I take 1 and I plug that then into my f function, f of 1 is going to be 0. So this one is going to equal 0. All right. Next one. If I do h of f of 1, so that means I'm going to do f of 1 first. Well, f of 1 is 0. And then I would do h of 0, which is, oh, that's not a point on the graph right there. Whoop. 5. H of 0 is 5. Okay. Let's keep it moving. F of negative 2. These always look weird when you have the f of f. So if I plug in negative 2 for f, negative 2 gives me 3. So now I need to plug in 3, because that was my new function value, right? When I went from here to here, I got 3. Now I'm going to plug 3 into my f again. F of 3 is positive 2. And then the last one, if I have h of negative 3, so I'm plugging negative 3 into h. So negative 3 gives me positive 3 as my output. So I'll plug in positive 3 for h, which is right over here, and gives me positive 3 as my output. Awesome. We did it. Not too bad for that video. 3 quick examples. Hopefully those do the trick for you guys when you're doing your homework. If you got questions, pop in, ask some questions. I love answering questions. You guys have a great day. Keep it real, keep it fresh. Always remember to do your best.